Hello, welcome back to AI Dev World. It is my pleasure to introduce our next speaker, Tony Holdstock Brown, CEO and co-founder of Ingest.
Hey, how's it going? I'm Tony, as mentioned, and in this talk, we're here to talk about productionizing and orchestrating AI and agent workflows in prod at scale using best practices. So I think a lot of talks have stemmed on agent demos, how you can build agents, how you can build these AI workflows, and really, really great demos, but there's potentially less talk about the systems and architectures that you need to develop and push to production in order to make these work inside your app at scale. So in this talk, we're going to go over how you productionize AI and agent workflows with an emphasis on the systems, the architectures, the patterns that you need, sort of the secret sauce to making them work. We'll also talk briefly about the systems and some of the new tools that will help you deploy these workflows at scale. So in order to kick it off, we're first going to talk about AI and agent workflows to contextualize some stuff. Be really quick. You've probably seen a bunch of these already, but let's define what an AI and agent workflow is using a really basic example. And this example is from a paper called Storm. Matt Pocock, if you follow him on TypeScript, he talked about this a few weeks ago. This is a basic AI workflow which, given a topic, is going to draft a comprehensive article, cites sources, it's non-biased, it has differing viewpoints, almost Wikipedia-like in quality, with just a topic. And so this particular workflow is really difficult to write. If you did a one-shot prompt, the chances are it might be biased, it might hallucinate, it wouldn't be able to generate sources. This workflow does all of that for you. So you can see at the beginning of a workflow, first you give it a topic. There are a bunch of steps. In this case, there are two initial steps that the workflow must do. First, draft just a basic generic outline. You can do that really easily with an LLM call. And the second is create multiple different perspectives. And this workflow does these steps in parallel so that you can speed up the response. So you get multiple steps. Maybe they are LLM calls, maybe they're inference calls, maybe they're things like RAG or tool use. Maybe they're regular code inside your workflow. They're often in parallel. And in this case, we run through generating perspectives, finding different sources to build up this workflow state. And this workflow state is kind of brings together all of the final things you need to put into context for the final LLM calls to generate the actual response. And this final state is used for the end of the workflow. That is a really basic example of a standard AI workflow. Agent workflows are really similar, except after calling an agent, maybe the agent responds with a tool use, and the tool is executed as part of a workflow step, and then the workflow continues and iterates. So workflows are essentially multi-step functions. And you might say, well, this is great, but like, why use them? Because this seems a lot more complex. And that's completely fair. In this case, workflows give you improved effectiveness. If you are doing a single shot prompt, the chances are it might hallucinate, it might give you incorrect information. By splitting things up into multiple different steps, you overall improve the effectiveness of your workflows. I don't know if y'all follow SweBench, Software Engineering Bench, but a lot of the recent state-of-the-art models and ways of working break things up into reading files, generating a plan for the code you're going to edit, passing that plan into another model as a separate step, executing on that plan using a separate model and a separate inference call. So breaking things up into multiple different steps is the only way to beat the current state of the art in terms of software engineering bench. So realistically, if you're going to be doing something slightly more complex, then workflows are the way forward. Again, fewer hallucinations, and in general, much more improved problem solving. And I think like you've got this whole concept of thinking models and whatnot that allows sort of inference calls time to think You can almost imagine workflow steps as doing the same thing, but embedding regular code, tool use, RAG use, and whatnot into the context, passing all of this workflow state back into the model to do a very similar thing, except you define that workflow yourself. And overall, if you build workflows, this gives your users a much better experience than single one-shot prompts that try to do everything. Super similar to regular engineering. You can have one package or one file that does everything. But if you break things up into separate packages, if you have separate function calls, your code is easier to maintain, easier to follow. Very similar thing with individual steps in workflows. Gives you a much better end experience. So knowing that AI and agent workflows are literally just step functions, how do you actually develop these? I'm going to first talk through the hierarchy and the mental hierarchy of how these work, sort of layer by layer. And then we're going to dive into how to actually build and productionize these systems inside your own company, inside your own product. So to begin with, you've got your base models, maybe the tool use, maybe RAG, maybe you're injecting context into these particular prompts. And these are API calls, pretty simple to write. And you write them and link them together using workflow code. Maybe it's, run model A, take a look at the model's responses, check to see if it's hallucinating as a separate step. This workflow code is orchestrated via some sort of runtime. Each particular step needs to happen either in sequence or in parallel. And this architecture, this particular systems piece, is the piece that people don't necessarily talk through that's really key to productionizing these. And we're going to dive into how the runtimes work underneath your standard workflow code. Your workflow code can literally be any code. It can be any framework as long as it does the sequence of steps for your AI and agent calls. So inside your orchestration, this is typically what you're going to get. If you recall the storm thing that we talked about, first we have generating an outline, and then we have generating perspectives. Those are two separate steps, which are two separate jobs because they may fail. You're going to need to build a queuing system to make this work, have some sort of queuing system. And then given, Bedrock doesn't have unlimited capacity, your API providers for inference don't have unlimited capacity, you need to figure out throttling, rate limiting, maybe cancellation of flows. And the workflows imply that this runs in the backend, so streaming of data to the front end as well. This is super important and the sort of fundamentals of how things work. And we're going to walk through some code which is written in sort of an agent runtime style, a runtime style way of working, specifically for AI that will exemplify this. So agent runtimes are basically systems that do this for you. They do the orchestration, they do the steps, they do the retries, and they do the state management, and a set of SDKs that make all of this transparent to you. But you can think of each particular step as basically a job in a queue, and we'll walk through how this works in both the runtime way and the classic orchestration systems type of way. So let's talk through how this works from the storm example that we shared previously. So here is an example storm workflow using agent runtimes. And you can sort of, this is a super abbreviated version, by the way. It's not the entire workflow, it's only a few steps of it. And I'll walk through the code step by step. So this is TypeScript. TypeScript is kind of like the lowest common denominator out there. Everyone understands it. It's got some good primitives like promise.all that will exemplify the parallelism stuff. So regular code. But this sort of stuff works in Python, Java, Ruby, Golang, whatever you want. Most of these systems will work in many different languages. So we're going to kick it off. Firstly, over here, in parallel, there are two steps in the promise.all, if you see this. In parallel, we are running one step to generate the outline and the second step to generate perspectives. And those are inside of a step.run. And a step.run is essentially a single job in a queue. You can think of it as a code level transaction. If the step fails, it's going to retry. And once it succeeds, it records the output of that inference call into workflow state. So in this case, we're chaining 2 jobs together, running them in parallel. Those will succeed and retry. And then if for example, you're rate limited and they retry and then they finally succeed, this promise.all is going to resolve, and you're going to have the variables here are going to be the result of those particular inference calls. So step.run is essentially a single job or a single step of your workflow. And you can write any particular code you want in here. It can be, a database call, it can be RAG, it can be an API lookup, it can be a tool use, it can be an inference call as well. This essentially abstracts the queue. If you're using one of these agent SDKs or agent runtimes, and if not, you are building individual jobs within a queue for each particular step in your workflow. The second thing it does, once they complete, is run another step. And in this step, we're taking the outputs of those previous steps and merging them into a second inference call. So this handles parallelism, it handles the queue, it handles retries, it handles everything for us. This is the concept of an agent SDK. And it gives you a bunch, which we'll quickly talk through. Let's talk about the specifics of how this works and what each step.run is, and some of the other things that you will need to build as you productionize this on top of your essentially queuing systems, which are the most important thing if you're going to be building and orchestrating AI. So step.run is your base building block for jobs in a queue, for workflow steps. As we kind of mentioned, it wraps any code and makes it transactional. And this can be any code. So if step.run errors, it's going to retry. And that's really great for durability, because sometimes API providers go down. It does handle the parallelism for you. And because this abstracts the queue for you, it generates inputs, outputs, traces, and observability automatically, which is also something that you will need to consider as you build and productionize these systems. You can totally add OTel to each particular API call, but doing this on a workflow run level is particularly important because you need to see how one inference call or one step leads into another. For example, if you have step A, which is RAG, and it loads some data from a database, or a vector store actually, and then step B merges the RAG output with a prompt, you'd want to see both the RAG output and the prompt as individual spans within your OTel, wrapped up within the context of one workflow run. Step.run will do that for you, but you need to make sure that you consider the context of an overall workflow run within your backend systems as you build out the jobs that flow from one to another. There's another API called step.waitForEvent, which will pause your workflows, suspend them when they're running automatically, and then it will wait for a matching event to arrive. And as soon as that event arrives, it's going to automatically resume the workflow and inject that event data directly into the workflow state. Basically, human-in-the-loop flows. If you want to wait for an approval, if you want to wait for something to happen, if you want to wait for an API call, that's totally fine. You can wait for a specific approval event to happen within your workflow. And as soon as this event is received, it's going to resume the workflow and continue from where it left off. So in this case, if you are building this yourself, you need your queuing system to handle jobs. You need to store workflow state in a database. And then you need to build a handle, basically a resume token for this particular workflow ID and workflow state. And as soon as an incoming event happens that would resume the workflow, you need to take that token, take the workflow state, create another job, and then push this into your job queue so that the workflow can pick up from where it left off. This essentially does all of that for you. And agent runtimes should handle this for you if you're using an API/SDK for building AI workflows. You should also handle the timeout case. For example, maybe you would like to have something approved within 4 hours. And if it's not approved within 4 hours, escalate or cancel the workflow. In this case, your resume token that you build, you would have a job that you enqueue for 4 hours time, and it checks to see if that resume token has been consumed. If that resume token has not been consumed, you can safely assume that the event hasn't been received within 4 hours, the thing did not happen, and then reconstruct the workflow state, create another job in the queue to then handle the failure case of that particular event. This will do it all for you. The APIs do that for you. But again, things to consider as you're building out these production systems. You should also be able to selectively stream information from your workflows to users. And typically this is WebSockets or server-side events. Specifically, you should be able to pick and choose data. For example, if we're talking about the Storm example again, it's highly unlikely that we would want to give all perspectives to the user immediately during runtime. We might want to filter those perspectives, mix them together, and go through the cycle in the Storm flow, and then share the fully defined perspectives afterwards. There might be some private data that comes from a RAG call that you don't want to send to users. So each particular step may or may not produce data that you could stream to the front end, and you need to be able to selectively choose which data to show. And so when you're building out your job queues or you're using these sort of SDKs, if you're building this yourself, you need to understand when and where you can stream data to the users. You need to build a system in which you track which users are interested in which workflows and then stream data directly to that particular user. Or you use the APIs here that will do that for you. And finally, you need to manage throttling, rate limiting, and concurrency, potentially on a per user basis. So for example, if you're running an app with 10,000 different accounts, and you have a limit within your API provider of maybe 10,000 requests per second, it's highly unlikely that you would like one account to use all 10,000 requests, and it's highly likely you would like to split your overall capacity amongst users. If you're using a solid agent runtime, you should be able to use multi-tenancy out of the box. And if you don't have that, you'd want to make sure that you build concurrency directly into your queue, potentially based off of tenant IDs within your system, to make sure that you are fairly provisioning capacity for each of your users. And this is sort of mandatory. There's no getting around the fact that capacity is limited, constrained. And there's no getting around the fact that you can't really give one user 100% of your resources. So this is the sort of stuff that needs to be directly built into your queuing and orchestration platform when you choose to do this. So at a high level, if you're using these sort of agent runtimes, you get step.run, which will queue new jobs to run invariants or do RAG or do chunking or do embedding, do whatever you need. You'll get things like queuing in the loop and step.wait for event built automatically. You'll get things like streaming built automatically. You'll get observability across every step and workflow run, which ends up building a really interesting data set that you can use for evals across your entire workflow instead of individual model calls, or across agents, which may be semi-autonomous. And that gives you the basis of a complete system that works to run agents and AI workflows. This all revolves around queuing and orchestration. And if you take a look at any reasonably advanced AI company, whether they're doing legal, healthcare, sales, or any sort of ops type challenges, you will see that they have input data and they'll run workflows step by step. An agent runtime sort of handle this for you. Why would you use a runtime instead of building this yourself is a genuinely good question. We've talked quickly about the infrastructure that you need, and this is largely the infrastructure that you're going to build up. You're going to build up queuing systems. You're going to build up your individual workers for each particular step in a job. You're going to write workflow code that manages each particular step. and then you're going to write observability on top of your queuing system. If you choose to use a runtime, a lot of this stuff will be given to you out of the box, and you focus on the flow of the code, which is just step A, step B, and step C. And in production, when you move this to your real world systems, you are going to continue to iterate on these particular workflows again and again. So choosing something that abstracts your orchestration layer, abstracts the infrastructure that runs all of this, is particularly important, so that you can continue to develop your workflows and rapidly iterate. Because iteration is particularly important when it comes to building AI at scale. So abstract your infrastructure as much as possible, make it extremely high level, but not super high level so that you're confined to a particular RAG implementation. There's like graph RAG, fast RAG, standard RAG. A bunch of that changes over time. It's better to abstract away the individual steps of a workflow than move super high level and abstract away maybe the way that you do chunking or embedding, because that's just application level code that can run in a particular workflow step. And this allows you to iterate relatively quickly. And honestly, in some cases, if you use these particular runtimes, us being one of them, move from zero to production in under a day, because the APIs are relatively simple and relatively easy to work with and run anywhere inside your own VPC. So high level, you really need to focus on the orchestration layer. Because reliability and durability is important alongside observability. Runtimes do a lot of that for you, and that's the crux of productionizing AI workflows. I don't know if there are any questions on AI runtimes, overall orchestration, the systems that you need to run at scale. Again, that's largely what the focus of this talk is all about. There was a question: can agents determine what steps to apply in a given flow? For example, if you had a flow where you're ingesting some kind of media and you wanted to make decisions, pre-processing, could an agent decide what flows would be provided and what set of tools? Yeah, that's a really, really good question. And I'm going to talk about deterministic standard AI flows and then agent flows and the differences between the two. Storm, the one that we ran through, was an example of a completely deterministic AI flow, series of steps that will always happen no matter what. Whereas agent flows may choose to run individual tools, and they may choose to run themselves in a loop. So high level, you've got your non-deterministic agent systems, your agent workflows, and you have this meta state that each particular agent builds up. And I'll quickly expand on that. Each particular agentic workflow has a particular goal and an outcome that you would like to achieve. And each particular agent workflow is going to build up state to hopefully advance towards that goal. And it can choose to run any particular tool that you give it. Typically, you would want to figure out which particular paths you expose on your particular agent workflow, because you need some sort of deterministic code to analyze the state and say, hey, my agents have finished running. That's done in a couple of different ways. Maximum times to iterate, and then just inspect the state and call it a day. Or specifically, each particular agent runs a tool. That tool actually updates state somewhere in your workflow, and then you have code that literally inside a for loop, every time it runs, inspects the state, and then says, given this particular path, given this particular information, I would like to run this next agent. And you can do that particular run through it's a for loop. You can do that particular analysis using basically your own code as a state machine, or you can pass that to another agent and say, hey, I've got a list of agents here. What do you recommend to do as a next step? It's totally possible to do that. And it's literally a for loop that runs each particular agent in a step. And the result of that agent call may be another tool that you run in a step within the same loop of the for loop. Or it may be something that updates state that on the next iteration of the for loop, you inspect, and then based off of the current state, which your agents have modified with tools and so on, you decide, is the workflow finished, or do we need to continue calling another agent? An agent is basically just a loop that does that for you. I hope that answers the question. If not, feel free to comment again, and I'll continue more. There are some example agents out there. Essentially, you're giving each particular agent a set of tools, and then you decide which particular agent to call based off of state. But again, for loop, and it does the same thing. Generally speaking, determinism beats non-determinism, which I think we all know as engineers. And so if you understand the categories of media that you're processing, maybe you have agents predefined using regular code for each particular category, and you have semi-structured workflows, and you choose to run a child workflow for each particular category. But it basically comes down to building up some sort of deterministic state that you can inspect, and the agents, which may be non-deterministic, still modify this state, which at a top level you analyze and then figure out what to do next. Awesome. Well, if no other questions, the main takeaway realistically is in order to build production AI systems, you want to focus on building workflows which are high level, orchestrated with a queue/agent runtimes, so that you can iterate on things relatively quickly. Examples in docs, yeah. There are examples in docs. There are examples on our system, Ingest. I'm sure there'll be a bunch of other runtimes coming out soon. We've been working on this for a few years. There'll be a bunch of other runtimes as well. There are examples in our docs. There's something called AgentKit, which does a lot of the agent loop for you. And there's a SweBench example in there that kind of just it took a day to build. And it answers a bunch of the Python examples really well using Anthropic. A bunch of examples with both AgentKit and on Ingest. And again, realistically, it's more about orchestration. And that's the key takeaway. The orchestration is particularly important. Cool. Awesome. If no other questions, thank you for the time, and super interesting seeing how the world changes over the next year. It's a fun time.